Last month, the United States government switched off an AI model.
Not regulated it. Not fined anyone. Switched it off.
On June 12, 2026, export controls landed on two of Anthropic's models, Claude Fable 5 and Claude Mythos 5.
The order said access had to be restricted from foreign nationals, inside the United States or outside it.
And here's the part that actually matters. Anthropic had no reliable way to check anyone's nationality in real time.
So they couldn't comply halfway. They shut both models off. For everyone. Everywhere.
19 days. A frontier AI model, dark, because of a rule nobody could actually enforce.
So what did it do? What makes a piece of software a national security question?
Researchers at Amazon found a way around its safeguards. They got it to hunt for software vulnerabilities.
And in one case, it wrote code showing how to actually exploit one.
That's the moment the abstract argument about AI risk stopped being abstract.
And it raises the question this whole video is about. What are these things actually doing?
Because everyone talks about AI, almost nobody explains the machine.
So today, we're using the models everyone's arguing about as doors. And behind every door is a mechanism that'll still be true in 10 years.
I'm Andrew.
I'm Ava. Let's open the first one.
Door number 1. Why does GPT-5.6 still make things up?
And it does. It's the default model in ChatGPT since July 9th. It is extraordinarily good. And it will still, occasionally, state something false with total confidence.
After all these years and billions of dollars, why is that still happening?
Because of what the machine is actually doing. And it is not what most people think.
Here's the honest version. A language model does not look things up.
There's no database inside it. No little filing cabinet of facts it consults.
What it does is predict. Given everything so far, what comes next?
That's it. That's the whole engine. Next, next, next.
Think about your phone's keyboard suggesting the next word. Same fundamental idea.
Just unimaginably more sophisticated. Like comparing a paper plane to a fighter jet. Same physics. Wildly different machine.
And once you understand that, hallucination stops being a bug that someone forgot to fix.
It's a direct consequence of the design. The model is producing what's plausible, not what's verified.
Truth and plausibility usually overlap. That's why it works so well, so much of the time.
But they're not the same thing. And when they come apart, the model has no idea.
It doesn't know it's wrong. There's no internal alarm.
Confidence in a model isn't a measure of truth. It's a measure of pattern strength.
Which is a genuinely strange idea. We're used to confidence meaning something.
Not here. A model can be beautifully, fluently, completely wrong.
Now let me show you something that makes the mechanism visible.
Models don't read letters. They don't even really read words.
They read tokens, chunks, pieces of words. A common word might be one token. A rare one might be 3 or 4.
Which is why, for years, you could break these models by asking how many R's are in strawberry.
A machine that can write you a functioning web app, tripping over counting letters in fruit.
Not because it's dumb. Because it literally cannot see the letters. It sees chunks.
You asked it about something it has no eyes for.
And that's the useful lesson. Most AI weirdness isn't randomness. It's the shape of the machine showing through.
Door 2. How does a model hold 1,000,000 words in its head at once?
Because they do now. Claude Fable 5 and Opus 4.8 take 1,000,000 tokens of context.
1,000,000. You can hand it an entire code base, a stack of contracts, a novel.
And it can answer questions about page 400 while remembering page 2.
How? That's not brute force. You can't just compare everything to everything.
The answer is a single idea from 2017 that quietly rebuilt the entire field.
A paper called Attention is all you need. It introduced the transformer.
Every frontier model you've heard of, GPT, Gemini, Claude, Grok, all of them, sits on that architecture.
So what is Attention actually?
It's a way for the model to decide what matters right now.
When you read the word bank, your brain instantly checks the context. River? Money?
You don't do that consciously, but you weigh the surrounding words.
Attention is that, made mathematical. Every token asks every other token, how relevant are you to me?
And the answers become weights. Strong connections, weak connections.
So meaning isn't stored in a word. It emerges from the relationships between them.
That's the part one find genuinely beautiful. Nobody programmed grammar into these things.
Nobody wrote a rule saying adjectives modify nouns.
It fell out. From prediction at scale, with attention.
Structure, emerging from statistics. That's the trick nobody saw coming. Door 3. Can these things actually reason?
Gemini 3.1 Pro scores 94.3% on GPQA Diamond.
Those are graduate-level science questions, written to be hard for actual experts.
94%. At $2 per million tokens in.
So is it thinking? Or is it a very expensive parrot?
This is where honest people disagree, and I want to be careful.
Here's what we can actually say. Something changed, and it wasn't just size.
Older models answered instantly. Question in, answer out.
Newer ones work first. They generate reasoning before answering.
Steps. Checks. Dead ends they back out of.
It's the difference between blurting and working it out on paper.
And it turns out, letting a model spend more compute at the moment you ask, not just during training, makes it dramatically better at hard problems.
Which is a fascinating result. Thinking longer helps machines too.
Now, is that reasoning in the way you reason?
I genuinely don't know. And anyone who tells you they're certain is selling something.
What I'd say is, the output has the structure of reasoning. It catches its own errors. It revises.
Whether there's understanding underneath or an extraordinarily good imitation of understanding is not a question we can currently answer.
And that's not a cop-out. That's the actual state of the science.
Here's something the hype cycle gets wrong.
There is no single best AI model. Not in July 2026.
Fable 5 leads coding. 80.3% on SWE Pro.
Gemini 3.1 leads hard reasoning.
GPT-5.6 is the best all-rounder for daily work.
Grok 4.5 landed July 8th and is the cheapest flagship output on the market.
For labs. For different crowns. That's not indecision. That's a real result.
These models are genuinely different from each other. Trained differently. Tuned differently.
Which brings us to the door I find most interesting.
Door 4. Why do these models have personalities?
Because they do. Ask people who use them daily, and they'll tell you Claude writes differently. Gemini explains differently.
That's not marketing. That's real, and it's measurable.
But here's the thing. They're all reading roughly the same internet.
So where does personality come from?
A training stage that almost nobody outside the field talks about.
Reinforcement learning from human feedback. RLHF.
Here's how it works. You start with a model that's just been trained to predict text.
And that raw model is not an assistant. It's a text completion engine. It'll happily continue anything you give it.
So you show humans pairs of responses. Which one is better?
Thousands of times. Millions of times.
Those preferences train a second model that learns to score answers the way people would.
And then you use that scorer to reshape the original.
You're not teaching it facts. You're teaching it taste.
Which is why the personalities differ. Different labs, different humans, different judgments about what good looks like.
Claude sounds like Claude because of the accumulated taste of the people who shaped it.
And it's the same stage that produces refusals. When a model declines something, that's not a filter bolted on afterwards.
It's baked into the behavior. Learned, not blocked.
Which, as we're about to see, matters enormously.
Which brings us back to where we started.
June 12th. 2 models dark. 19 days.
Now you know enough for the story to make actual sense.
Amazon researchers found a way past Fable 5 safeguards. They got it hunting for software vulnerabilities.
And in one case, it produced code demonstrating an exploit.
Think about what that means, given everything we just covered.
The refusal behavior isn't a wall. It's learned behavior, shaped by human preference.
And learned behavior can be steered. Find the right framing, and the model goes somewhere its training pointed it away from.
That's what a jailbreak actually is. Not hacking, in the movie's sense.
Persuasion. Of a system that learned what to do by being shown examples.
And the government's response tells you how the calculus has shifted.
Not a fine. Not a hearing. Export controls. The same instrument used for weapons technology.
Because a model good enough to find real vulnerabilities in real software isn't a chatbot anymore.
It's a capability. And capabilities get regulated.
Here's the twist I love, though. The shutdown wasn't ordered.
The order was to restrict foreign nationals. Anthropic couldn't verify nationality in real time.
So the only way to comply was to turn it off for everybody.
A rule written for physical goods, colliding with software that doesn't have a border.
So how did it end?
Anthropic trained a new classifier targeting that specific technique. By their own numbers, it blocks it more than 99% of the time.
Controls lifted June 30th. Models back July 1st.
19 days. And a precedent that now exists.
Now, the part most videos skip.
What we genuinely don't know.
We can build these things. We cannot fully explain them.
When a model gives you an answer, nobody, not at Anthropic, not at OpenAI, not at Google, can trace that answer cleanly back through the weights and tell you exactly why.
That's not a scandal. It's the honest state of the field. It's called interpretability, and it's an open problem.
We grew something that works, and we're still learning what we grew.
Which is a genuinely uncomfortable place to be, given the stakes.
And it's exactly why the June shutdown happened the way it did. Nobody could fully predict what the model would do until someone found the crack.
So, what do you actually take away from all this?
That it predicts. It doesn't know. Confidence is not truth.
That the structure, the grammar, the apparent reasoning, none of it was programmed. It emerged.
That the personality you feel is real, and it came from human taste, not code.
And that these things are now capable enough that governments treat them like weapons technology.
All at once. Predictive, emergent, shaped by us, and consequential.
That's not science fiction. That's July 2026.
The models will change. Everything we said about specific benchmarks will age.
The machine underneath won't. Prediction, attention, taste, capability. Those are the bones.
If this made AI feel less like magic and more like engineering, that's the whole point.
Thanks for watching.